This challenge is called Sleuthkit Apprentice. It's a medium-level challenge in the forensics category from the picoCTF 2022 event. The description says, download this disk image and find the flag. Note, if you're using the web shell, download and extract the disk image into /tmp, not your home directory. And then we have a link to the compressed disk image over here. So the first thing we need to do is we need to download this, we need to copy this disk image to our clipboard. So to do that, we need to highlight the link and then right click and then select copy link address. After we've done that, we're going to go over to our web shell. And in the web shell, we're going to create a directory inside the TMP directory to work inside of. So we're going to do make directory. It's going to be /tmp/ and then some sort of username. So I'm going to use my username, the shy hat. And that's going to create the directory that we're going to be working inside of. So next we need to enter that directory. And then we can download the file. So it's going to be wget and then space and then paste in the file address and then hit enter to download the file. So after we're done, we'll see that this .gz file is in the directory. So the .gz file is a compressed file, so what we need to do is we need to decompress it first before we can use the image. So we can do that with the gunzip option and then just supply the name of the file and then hit enter. And that's going to take a moment or two to decompress. So after it's done, we'll see that we have this disk.flag.img file over here. So this is a disk image file. If we use the file command on this file, we'll see that it is a mbr boot sector file. So this is what we want. Okay? So the next thing we're going to do is we're going to start to do some enumeration on it using some tools from the Sleuthkit. So the first one we're going to do is we're going to run mmls, which is going to retrieve the partitions on the disk image. And we're going to run that with the name of the file. And we're going to see that there are 3 potential partitions to look at. There's this Linux partition at offset 2048. There's another Linux partition over at 206848 and another Linux partition over at 360448. So in order to enumerate these, we're going to use the offset along with the fstat command. So the fstat command is going to get information about these partitions. So it's fsstat, and then we have to supply the offset. So we're going to do the lowest one first, 2048, and then the name of the file. And it gives us a lot of information, but importantly, it gives us this information over here. So the type of file system being used, which is ext4, and we're going to need to use this in our other enumeration commands. So we're going to go back down, and we're going to enumerate the other potential partitions. So first we did 2048, and now we're going to do 206848. And then it says it cannot determine the file system type. So we're going to skip that one, and we're going to move on to the partition at 360448. And this one is also valid. If we go back up to the top, we'll see that this is also an ext4 partition. So we're going to need to use that information when we're enumerating that partition as well. So we're going to go back down, and then we're going to clear the screen. The next step we're going to do is we're going to do some file ls rather, so the fls command, file system ls, and we need to supply the file system type, which is ext4, and then the offset, which is 2048, and then the disk image name. So when we do this, we're going to get the contents of the file system. Oh, one more thing that we need to do is we need to include the -r flag, which stands for recursive, and it's going to get us all of the files that are inside of directories as well. So we see here there are not very many files in this particular partition. There are just a few files, and so there's nothing particularly interesting here. So we're going to move on to the other partition that was valid, which is the one over at the offset 360448. And there's a lot of files in here. But if we scroll up a little bit, we're going to see some interesting files right over here. So in this section over here, we've got 3 files that we might be interested in that are under the root directory here. There's this .ash_history file, there's the flag file, and there's the flag.uni.txt file. So the first thing that we might be interested in looking at is this flag.txt file, since we're mostly looking at ways to read flags inside of these CTF challenges. So we have to note the inode numbers. So the inode numbers are these numbers over here. So this one over here for .ash_history is 2363. The one for flag.txt is 2082. And the one for this other one called flag.uni.txt is 2371. So we're going to go back down. And we're going to use the icat command. So the icat command is going to allow us to read files in a disk image, and we're going to have to supply the offset of the partition as well as the inode number. So it's going to be, we're going to also have to supply the file systems, which is ext4, and then the offset, which is 360448, and then the name of the image. And the last thing we want to do is we're going to supply the inode number. So this first inode number is for the flag.txt file, and we're going to see that this actually does not contain the flag, but we're going to check out the next file, which is the flag.uni.txt file, which is at 2371. And this actually contains the flag. But before we finish this challenge, we're going to take a look at what actually happened to the flag.txt file, and we can do that by looking at the history file. And the history file is located at 2363. So when we look at this file, we see the command history of what happened inside the terminal. So inside the terminal, the flag file was created using nano, and then there's this iconv file, command, which is used to switch text encodings. So in this case, we're going to start with ASCII and we're going to convert it to UTF-16. And we're going to run it on flag.txt, so the contents of that file. It's going to be output to flag.uni.txt. So that's what happened to flag.uni.txt. That's how that file was created. But we also see that this shred command was used. And the shred command was used on this file right here, flag.txt. Shred is a command on Linux that can be used to delete files. But not only delete files, but delete all the bytes that were associated with that file on the file system, which means that it would be very hard to recover using digital forensics procedures like the ones that we're doing right here. So that's what happened to the flag.txt file, and that's why we can find the flag in flag.uni.txt. So what we can do now, because we've now discovered the flag, is we can go back up to the flag over here and copy the value. Then go over to the challenge description, and at the bottom over here, we can paste in the flag value and click on Submit Flag, and then we're finished.
Hey there, HackerFrogs! Are you enjoying this workshop? Learning new concepts and skills? If so, there's a way you can support the channel, and it's totally free. Just click on the subscribe button below the video. Also, click on the like button. And if you have questions or comments on this workshop, please leave them below the video. Thanks for listening. And now, back to our scheduled programming.